To integrate this, I would rewrite this as follows. What I will do, I will multiply the numerator by sine of a negative b, and I divide the quantity by sine of a negative b. You got this quantity in the denominator. Rewrite it as it is. Cos of x negative a times cos of x negative b. This is multiplied with dx, and we have to integrate this. Now this is a constant, so push this out. So it's going to be 1 over sine of a negative b integral. Now I want to have x negative a and x negative b. So to get that, I'm going to add a x and I'm going to minus a x. So this is going to be positive. I actually wanted to, okay, so let me just have that a followed by a negative b and a negative x. Positive x, negative x gets cancelled, so no harm is done. And this is divided by cos of x negative a times cos of x negative b. Now I want to, or I would rewrite this as integral sine of, as two terms, a negative b, right? So for that I have to, perform some manipulations in this part. So I need to have x minus b. So I'll start with x minus b, and then I'll place a negative sign, and I need to have x minus a. Outrightly you can simply place these terms and you will get the solution. Of course you will have to also check it out if this adds up to this quantity. X negative b, negative x, so x gets cancelled, so negative and negative positive, so a is positive, b is negative. Fair enough. Now this is divided by cos of x negative a multiplied with cos of x negative b times dx. Now I'm going to utilize this formula, sine of a negative b, which is sine a cos b negative cos a sine b. So this is equal to 1 over sine of a negative b integral. You expand this using this formula. This is sine of x negative b times cos of x negative a negative cos of x negative b times sine of x negative a divided by the denominator, cos of x negative a multiplied with cos of x negative b times the dx. Now I will split and rewrite this as 1 over sine of a negative b. This integral is going to be sine of x negative b times cos of x negative a divided by cos of x negative a times cos of x negative b multiplied with dx negative cos of x negative b times sine of x negative a divided by cos of x negative a times cos of x negative b times dx. Now cos of x negative a, cos of x negative a gets cancelled. Cos of x negative b, cos of x negative b gets cancelled. However, there is a parenthesis there. So this is equal to 1 over sine of a negative b integral sine of x negative b divided by cos of x negative b multiplied with dx negative sine of x negative a divided by cos of x negative a times dx. Now this is a straightforward integration, right? So if you were to integrate this quantity can easily be, this is going to be tan, and you can integrate this by taking a substitution, or if you are not really familiar, let me show you the way in which we can integrate. So let me just say, consider integral sine of x negative b divided by cos of x negative b times the dx. Now I'm going to take cos of x negative b is equal to sum t. I differentiate, I get negative sine of x negative b multiplied with dx is equal to dt This is sine of x negative b times dx is equal to negative dt. Okay, so this is negative dt divided by t is equal to negative ln t, which is going to be negative ln of cos of x negative b. Okay, now you can just place the modulus. I'm not going to place the arbitrary constant now. Now you consider the next term. What is the next term? Consider integral sine of x negative a divided by cos of x negative a times dx. So if you were to integrate this, you get negative ln cos of x negative a. Okay, so therefore this quantity, if I were to take this as say sum 3, I can rewrite 3 with the information that I've got now. So therefore 3 can be rewritten as 1 over sine of a negative b. The first quantity is going to be this negative ln modulus cos of x negative b. The second quantity has already got a minus here, so that would mean I have a positive sign here. So positive ln modulus of cos of x negative a. Okay, so this is similar to ln of a negative ln of b, which is equal to ln of a over b. So if I were to utilize that, this is going to be 1 over sine of a negative b ln modulus cos of x negative a divided by cos of x negative b. So the modulus sign is actually covering all this. Now we have completed the result. So place the arbitrary constant c, and that is the solution for this question. So this is a lovely question. We will move on to the next one. Now we can rewrite this by splitting. So it's going to be sine squared x divided by sine squared x cos squared x times dx negative cos squared x divided by sine squared x times cos squared x times dx. Cos squared x, sine squared x gets cancelled. This is going to give me integral dx over cos squared x negative integral dx over sine squared x. Now cos squared x is going to be secant squared x, and that's 1 over cos squared x followed by negative. This is going to be cosecant squared x dx. Now when you integrate secant squared x, you get tan x. But when you integrate cosecant squared x, you get negative cot x, right? Now this can be rewritten as tan x positive cot x positive arbitrary constant c. So that's the solution for this question.